So very good evening, children. The last part of the videos we have seen in wave optics. What is wavefront? What are the different shapes of the wavefront? Also, we learnt how to apply Hygiene's principle for construction of wavefront. What are the wavefront we constructed in the previous lesson? That means previous topic we learned. We constructed spherical wavefront and also we constructed plane wavefront by using Hygiene's principle. And the next module, we have learnt the interference of light waves. In that interference of light waves, in order to get a sustained interference on the pattern, that means a permanent interference, get a sustained interference on the screen. Sustained interference on the screen, we have to use, number one, coherent sources of light. Coherent sources of light. So we have seen what are coherent sources of light. Because two independent sources cannot form a coherent source because they cannot maintain a constant phase in due course of time while they are traveling from different sources of light. So they may be a phase change. So therefore, to get a sustained interference, to get a permanent interference pattern on the screen, you have to use coherent sources of light. So what are coherent sources of light? The two important point. The two sources of light said to be coherent only if they possess same frequency. They possess same frequency and they maintain constant or no phase difference. Constant or no phase difference. Same frequency, of course, same wavelength. No phase difference. If these two criteria are mentioned, is going to be satisfactory, then you can say that the sources are coherent. But no two independent sources are coherent. Therefore, in order to get a coherent source, first use a monochromatic source. Monochromatic source. Mono means single, chrome means color. So monochromatic source you light use. From the monochromatic source of light, you set up, in the path of the light source, you set up two narrow slits, plane parallel to each other, plane parallel slits. The light from the monochromatic source of light falls on the two slits. These two slits are considered to be a coherent source. Why? Because from the two slits, the light waves emerging out will have same frequency. How do you say? Because they are emanating from the same monochromatic source. Only one source, that is mono means single colored source, single frequency, single wavelength. So let me call this wavelength as lambda or frequency as mu. So the light waves come from the monochromatic source and then these two sources produces. So this is crest and this is also crest. And this is trough. Dotted lines and here it is trough. Similarly, this is crest and this is trough. Crest and crest of one wave. So let me again repeat here. So the dotted lines represent trough. You can see here crest of the first wave, S1 wave, green color, and the crest of the second wave. So that is from S2. Both are arising at the same time from the source, from the monochromatic source, and then fall on the slits, and from slit S1 and S2 at the same time it is emerging out. So the crest of one wave and the crest of another wave superimpose, and the next here trough is formed. So let me draw the trough here. So with black color. So let me draw the trough here. So this is trough. Similarly here also trough. And the next here crest, and then here crest, and then next trough, and then next crest, and then here also next crest. So when you see that on the screen, I have not scaled and then drawn. If you have scaled and then draw, we have already seen in the simulation. If you scale it and then you draw. So definitely, you may be definitely noticing it like exactly at the center, you will get a maxima. So therefore, it is called as central maxima. What is it called as? Central maxima. Because crest and crest is overlapping. Similarly, wherever the crest and trough is overlapping, then you can say that you get minima. And similarly, here also the crest and trough is overlapping, so you get minima. So when you see the screen, on the screen, alternate dark and bright bands are produced. Maxima is called as bright band, and then minima is called as dark band. Again, what happens here? You will get bright band. Here you will get bright band. So likewise, continuously alternate bright and dark bands will be produced on the screen. So this kind of superposition of two waves arising from the coherent sources of light, you call it as interference. In this interference, very interestingly to be noted, the energy is, law of conservation of energy is not violated. So conservation of energy is not violated. The energy which is lost in the dark band is equal to or compensated by the energy gained by the bright band. So on the whole, on an average, conservation of energy is not violated here. So all that we have seen in the previous video. So now we will see here the resultant amplitude, which you have already discussed. So let me again recap the same thing. The resultant intensity of the two waves. Resultant intensity of two waves in the interference. Resultant intensity of interference. Interference is IR is equal to IA plus IB plus 2 into root of IA IB cos phi. So this is the resultant intensity of the two waves, which you have already discussed. Now, this resultant intensity can also be derived by alternative method. What is that alternative method? Aliter method. Aliter method, instead of taking two independent, that means two individual amplitudes. So I am going to take, let y1 is equal to a cos omega t and y2 is equal to, again same amplitude I am taking, a cos omega t plus phi. You may be wondering what is phi. Let phi be the constant phase difference. So I have noticed it, constant phase difference. Phi be the constant phase difference between two waves arising from what source? What source? Arising from coherent source. Why do we need coherent source, children? Already we discussed, in order to get a sustained permanent interference pattern on the screen, we require coherent source. So therefore, I'm using a constant phase, that means I'm using a coherent source, hence constant phase difference between the two waves is maintained. By the principle of superposition, by the principle of superposition, by the principle of superposition, y will be equal to y1 plus y2. When add together, so y will be equal to a cos omega t plus a cos omega t plus phi. So this is in the form of cos c plus cos d. So if cos c plus cos d is there, So you must be knowing in mathematics, cos C plus cos D is equal to cos of C plus D by 2 into cos of C minus D by 2. So therefore, what is C here? C is omega t. What is D here? Omega t plus 5. Omega t plus 5. So what is C plus D? 2 omega t plus 5. What is C plus D divided by 2? So that is equal to omega t plus 5 by 2. What is C minus D divided by 2? Minus 5 by 2. So therefore, so I am going to substitute the same thing here. So therefore, y will be equal to 2a into, so cos C plus cos D is 2 cos C plus D by 2. So I'm sorry, 2 cos C plus D by 2 into cos C minus D by 2. So 2a cos C plus D by 2. So omega t plus 5 by 2 into cos C minus D by 2. That is cos of minus 5 by 2. Children, what is cos of minus theta? You must have learnt in mathematics. Cos of minus theta is cos theta. So therefore, I am rearranging it. I am writing is 2a cos 5 by 2 into cos of omega t plus 5 by 2. This is in the form of y is equal to, this is in the form of y is equal to a cos omega t plus 5 by 2. So therefore, where a is the amplitude, this a is the amplitude. A is the amplitude of the wave. Amplitude of wave, which is equal to 2a cos 5 by 2. And children, we have already learnt, according to Young scientist, intensity is directly proportional to amplitude square. Is directly proportional to amplitude square. So that is only in wave nature of the light. In wave nature of light, intensity of the light wave is directly proportional to amplitude square. More the amplitude, that means more is the intensity. So therefore, I can say intensity is equal to, this is amplitude, we have already found out 2a cos 5 by 2. So that is equal to 2a cos 5 by 2, the whole square. So that means taking out the proportional of a constant k. So I is equal to 4a square, constant k is equal to 1. So 4a square cos square 5 by 2. Or I can write it as intensity is equal to 4I naught cos square 5 by 2, where I naught is nothing but a square over here. So 4I naught cos square 5 by 2. So when do you get I is maximum? I is maximum only when cos square 5 by 2 is equal to 1. So therefore, I max is equal to 4I naught. So this is an alternative method of finding out the resultant intensity. So either you can write down the intensity as IR is equal to IA plus IB plus 2 root IA cos 5, or you can write it as 4I naught cos square 5 by 2. You may be wondering, why don't you get the same answer? Yes, you will get the same answer. Put IA is equal to IB is equal to I naught. Then you will get IR is equal to I naught plus I naught plus 2 root I naught square cos 5. So same thing you will get 2 I naught into 1 plus cos 5. So what is 2 I naught into 1 plus cos 5? 4 I naught cos square 5 by 2. So you will get the same thing only. So there we have taken same intensity, but here we are taking two different intensities. So that is all. Now coming to the interesting, topic of that, continuation of the same topic, that is condition for maxima and minima. So condition for maxima and minima. After finishing, we'll go to the interference YDSC experiment. Maxima and minima. Condition for maxima and minima. So now I'm going to take maxima. So we have already seen, and again I'm just giving you a recap. Before getting into the maxima and minima, so I would like to, recapitulate this portion, that is this topic which you have already learnt in class 11. So now, what is the relation between Path and phase difference. Path and phase difference. How do we find out the relation between path difference and phase difference of a wave? So this is a wave. The total length of the wave is going to be lambda here, and the phase angle is 2 pi. Now for the phase angle 2 pi, the length is lambda. Therefore, for phase angle delta phi, what is the length? That is delta x. So this is the relation between path and phase difference. So recapitulate that. So condition for maxima, let us see. We know that I is maxima, I max is equal to IA plus IB plus 2 into root of IA IB cos phi is equal to 1. So for maxima, so therefore I put it like that. So therefore I max will be equal to square root of IA plus square root of IB the whole square. So this is equation 1. Similarly, I minima is equal to IA plus IB plus 2 root IA IB. 2 root IA IB cos phi becomes minima means cos phi should be equal to minus 1. Maxima means cos phi should be equal to plus 1. So therefore, I minima can be written as root of IA minus root of IB the whole square. So that is equation number 2. Now, we have already seen that cos phi is equal to minus 1 here. So this is first number 2. Cos phi is equal to plus 1 for maxima. And here cos phi is equal to minus 1 for minima. When and all you will be getting plus 1. What angle you will get? You will get 0 degree, 360 degree and so on. So therefore, phi will be equal to 2n pi. You put n is equal to 0. So you will get 0. If you put n is equal to 1, 2 pi, then also you will be getting cos phi is equal to 1. So n is equal to 0 you give, then you will get 5 is equal to 0. So cos 0 is equal to 1. N is equal to 2 pi, then you will be, similarly here, phi will be equal to 2n minus 1 into pi. When I put 2n minus 1 into pi here, where n is equal to 1, 2, 3, etc. So here also n is equal to 1, 2, 3, etc. Okay, so phi I found out. Here also phi I found out. This is for maxima and this is for minima. So therefore, path difference, this is called phase difference. Phase difference. This is path difference I'm going to find out. Path difference is equal to, use this formula. So path difference delta x is equal to lambda by 2 pi into delta phi. So 2n pi. Pi get cancelled, 2 get cancelled. So therefore delta x is equal to n lambda. So this is the condition for maxima. Similarly, minima. So path difference. So for minima, path difference, delta x is equal to lambda by 2 pi into 2n minus 1 into pi. Pi get cancelled. So delta x will be equal to 2n minus 1 into lambda by 2. So I'll just show you this. So 2n minus 1 into lambda by 2. So this is path difference minima. So I found out maxima as well as minima. So 3 things you have to know. I maxima, root of IA plus root IB the whole square. Then what is the phase difference and path difference condition for maxima? For phase difference 2n pi, whereas for path difference it is n lambda. Similarly, for minima, phase difference 2n minus 1 into pi and path difference 2n minus 1 into lambda by 2. Okay, right, next. So now special case, special cases. We know that I max is equal to root of IA plus IB the whole square. So I max is equal to root of IA plus root of IB the whole square. And what is I minima? That is equal to root of IA minus root of IB the whole square. So therefore, what is I max by I minima? I max by I minima is equal to root of IA plus root IB the whole square by root of IA minus root of IB the whole square. But we know that instead of taking this, I'm going to take IA outside from the numerator or IB outside from the numerator. So you can take it, root IB, take it out. So when you take out the root IB here, root of IA by IB plus 1 the whole square by, similarly here also root IB, you take it, root IA by IB minus 1 the whole square. Root IB get cancelled. So therefore, I max by I minima is equal to square root of IA by IB plus 1 the whole square by square root of IA by IB minus 1 the whole square. Why do we need to learn all that? This is for solving numericals. Do you know that the intensity is directly proportional to amplitude square? Yeah? Intensity is directly proportional to amplitude square. Do you know? Yeah, we learnt. So hence, we are going to substitute here. So since intensity is directly proportional to amplitude square, so therefore, I can also write it as I max by I minima can be written as, see, that is equal to, instead of root IA by IB, amplitude square, so A square by B square plus 1, the whole square, divided by root of A square by B square minus 1 the whole square. Or simply I can write it as A by B plus 1 the whole square by A by B minus 1 the whole square. You got it? Got it or what? Intensity max by I minima is root of IA by IB plus 1 the whole square by root of IA by IB minus 1 the whole square. But amplitude A by B plus 1 the whole square divided by A by B minus 1 the whole square. Sometimes you will be given the ratio of the amplitudes. Sometimes you will be given the ratio of the amplitudes. Then you will be asked to find out the intensity ratio. In this case, you can do it directly by knowing the formula. I hope you understand this. Now, we will go to the YDSC interference. Right. Interference, this is Young's double-slit experiment. Young's double-slit experiment. Young's double-slit experiment. This is simply called as YDSC. You can notice this NCERT diagram. From this is the source of light, monochromatic source of light. It is allowed to fall on the two slits S1 and S2. And the two slits S1 and S2 form a coherent source. Superposition occurs and then a wave pattern, that means intensity pattern, is falling on the screen. So this is the standard diagram here. S1 and S2 are the two slits. The light waves interfere and there is a possibility to meet at point O. There is also a meet at point P. So if it is going to meet at point O, of course, there is no phase difference. We know that. So we have seen that already. So we will just see here. But at the same time, if it is going to meet at point P, for example, here it is point P, then you can say from the central point, there is a phase difference. You can notice it. Or if the point P is going to be here, here also there is a phase difference. So therefore, you can notice the same thing. So therefore, wherever it is going to be, the path or phase difference remains constant. That is our motive of getting the sustained interference. So let us see that how it is possible. So now Young's double slit experiment, YDSC, I am going to derive fringe width, beta. What is fringe width? Distance between alternate bright bands, distance between alternate bright bands or dark bands, alternate bright bands or dark bands obtained on the screen, dark bands obtained on the screen. There are several methods of doing it. So let me choose one method of doing it. So this is two slits, that is S1 and S2 from monochromatic source. This is coherent source. Now let us suppose the screen is at a distance capital D from the slits. And let us suppose the distance between the two slits, let me call it as small d over here. So small d is distance between two slits, distance between two narrow slits. And of course, WA is nothing but width of first slit W1 you can take or WA, anything, width of first slit, and WB is nothing but width of the second slit, and of course you have to know that intensity is directly proportional to width of the slit. Intensity is directly proportional to width of slit. And later on we can see that about it. Just I'm giving you the hint about it. So now this is central point, and of course we know that central maxima. But at the same time, if the point P is going to be chosen over here, which is at a distance x from the central maxima, then there will be a path difference. Hence, there will be a phase difference. So let us find out here S2P, this is S1P. Got it? Now, this distance, let me call it as MP. This distance, let me call it as NP. So, hope you understand. N to P distance. O to P is X. So, what is N to P distance? This is nothing but D. So, this is D by 2. So, this is also D by 2. Do you understand? Distance between S1 and S2 is D. So, what is distance from S1 to the central point? That is D by 2. From the central point to S2, that is also D by 2. So, now, what could be the answer here? This is D by 2. O to P is X. This O to P is there, no? So, this O to P is X. O to N is D by 2. So, what is N to P? Can you analyze and find out? O to P is X. O to N is D by 2. What is N to P? N to P is X minus D by 2. Similarly, M to P, what is that? M to P. O to P is X. And M to O is D by 2 here. Look at the diagram. Yes, D by 2. So, therefore, what is M to P? MO plus OP. What is MO? D by 2. So, therefore, M to P is X plus D by 2. Why is it important to learn? Let me teach you why is it important to learn. I'll just go to the next page. Why it is important to learn? I'm going to find out the path difference. So, what is the path difference here? Path difference is nothing but delta x, which is equal to S2P minus S1P. That is what I wanted to find out. Hence, I am doing all that. In order to find out S2P minus S1P, I am going to take the triangle S2, triangle S2MP. From triangle S2MP, what is S2P the whole square? I am going to apply binomial theorem. S2P the whole square is equal to D square plus S2M the whole square plus MP square. So, that is X plus D by 2 the whole square. So, therefore, S2P is equal to, so S2P the whole square is equal to D square, take it out, 1 plus X plus D by 2 the whole square divided by D square. Okay, right. Similarly, what is triangle? Okay, let me finish off this. So, what is S2P? Taking square root. Come on, you know it. 1 plus X plus D by 2 the whole square divided by D square whole power half. So, this is equation number 2. Similarly, when you take triangle S2, S1MP, S1NP you take it. Now, listen here. S1NP you take it. When you take S1NP here, you may be able to understand that S1P the whole square is equal to D square plus X minus D by 2 the whole square. So, therefore, you will get the same thing. So, here S1P is equal to D into 1 plus X minus D by 2 the whole square by D square whole power half. Now, I'm going to apply binomial theorem. Apply binomial theorem. When do you apply binomial theorem? Whenever the value of 1 plus x whole power n, x is very much lesser than 1. Same way, binomial theorem I may apply. So, this half will come inside. So, when a half is coming inside, S2P will be equal to D into 1 plus half into x plus d by 2 the whole square by d square. Similarly, S1p will be equal to d into 1 plus 1 by 2 into x minus d by 2 the whole square by d square. So now you find out what is S2p minus S1p. That is all. S2p minus S1p is equal to delta x. So I can write here delta x. So that is delta x, which is equal to d. Take it out. So d you can bring it inside. So d minus d get cancelled. So this d I'm bringing it inside. So when if I bring it inside, 1d get cancelled. So 1d is getting cancelled. So therefore, what is the resultant you get? So you will get half into x plus d by 2 the whole square by d minus x minus d by 2 the whole square by d. A plus b whole square minus a minus b whole square, 4ab. So delta x is equal to x small d by capital D. 2 get cancelled. A plus b whole square minus a minus b whole square. What is that? 4ab. So 4ab when you take 4x into d by 2. So 4x into d by 2. So that will become 2xd. 2 get cancelled. So xd by d. So that is how you get it. You got it. So therefore, you get delta x is equal to xd by d. What is x? X is the distance from central maxima to nth maxima. Distance from central max to nth maxima or nth minima. Okay, so now we found out that. So therefore, delta x is equal to x small d by capital D. Now, for bright band, so we know that for bright band, delta x is equal to n lambda. So therefore, n lambda is equal to x small d by capital D. So therefore, x is equal to n lambda capital D by small d. What is x? Just now I told you, distance from central maxima to nth maxima. This is very important formula. Distance from central max to nth maxima. Okay, right? Central maxima to nth maxima we found out. Now first maxima. I'll take first maxima. Distance from central maxima to first maxima. So that is x1 is equal to 1 into lambda capital D by small d. Next, second maxima you take. Second maxima, x2 is equal to 2 lambda capital D by small d. So therefore, what is x2 minus x1? That is nothing but fringe width beta. That is equal to lambda capital D by small d. So from this, what did you understand? We understand that the distance between consecutive bright band or consecutive dark band, you call it as fringe width. Now we found out only bright band fringe width. Similarly, dark band fringe width. We will find out dark band fringe width. So we know that delta x is equal to 2n minus 1 into lambda by 2. Here we found out and delta x is equal to xd by capital D. So equating this equation, equating both. When you equate both, 2n minus 1 into lambda by 2 is equal to x small d by capital D. So therefore, x is equal to 2n minus 1 into lambda capital D by 2d. Here what is x called as? This is very important equation. Distance from central max to nth minima. So similarly, here what is x2 minus x1 you find out. That will be equal to beta. You get lambda capital D by D only. So from this, one can understand that whether it is going to be dark band or it is going to be bright band. So here you can say that fringe width is going to be the same. Fringe width beta is same for dark or the bright band. Bright band or dark band. So fringe with beta is equal to lambda capital D by small d. Okay, does fringe width depends upon the medium? Yes, because beta is directly proportional to wavelength of the light. Suppose if the entire apparatus is immersed in water, I can say beta in water is equal to lambda in water capital D by D. But what is lambda in water? Lambda in water is equal to lambda in air divided by mu into capital D by D. So therefore mu is greater, so therefore beta in water decreases, so is less than beta in air because mu is greater, right? These all insights question. So hope you understand, children. So till this you learn, we'll continue that the rest of the question as well as numerical based on the fringe width intensity pattern. So I wanted you people to know about the intensity pattern because I've told you fringe width is same. So therefore, since the fringe width is same, how does the intensity pattern looks like? So this is how the intensity pattern is looking like. Yeah. So this is interference intensity pattern. So you can see here, this is central max. And this is first max. This is second max. And this is first dark, second dark. So therefore, what you can understand on either sides, the distance between the two maxima, that is first maxima and second maxima, is same as that of the distance between the two minima. So therefore, fringe width is same. So till this you learn, and thank you, children. We will meet in the next module.